revision session for grade 10 March exams. So we are going to look at the remainder of the paper that we had started yesterday. We had actually ended off on the note of factorization. We factored this, right? Just remember, guys, that the golden rules that apply whenever we factorize are that one, we need to first count how many terms we have. Very important. How many terms do you have? That's something that's very important you need to first account for. And remember, terms are separated by plus and minus signs. So for instance, for these, there are two terms because one, the minus sign separates this term. So there are two terms here. Two, the second question you need to ask yourself is, should we apply what we call the sign change rule? And guys, the sign change rule is applied whenever you can see that, for instance, you see this 27 minus x cubed. These are two terms, but then what you notice is that we have a constant term that is at the beginning, whereas we are ending with a variable with an exponent that is 3. So this is a situation where if we apply the sign change rule, this is what we should notice. We take out a negative sign and then we swap around the x cubed and the 27. And by so doing, the sign change rule has been applied. Okay, taking the negative sign back gives me back the negative x cubed. Taking the negative sign into the negative times negative gives me back the positive 27. So the sign change rule here could be applied so as to ensure that the first term is containing the degree of the highest exponent for the variable. Or we could reorder the terms, write this first and then write that last, and then take out the highest common factor. Okay, so either way, that's fine, right? Then 3, after the sign change rule has been applied, if it is necessary, okay, we apply the sign change rule only if necessary. 3, we then have to consider what is the highest common factor. The highest common factor, guys, is considered as taking out the highest common factor first sign, right, which is usually the sign of the first term, okay, which has the degree of the exponent. Okay, then 2, the highest common factor number. All right, so we have to take out the highest common factor number if there is one. Then 3, we need to take out the highest common factor letter of the alphabet, or we call the variable. And by the variable we mean the exponent variable, that is the lowest. Okay, and that is actually common as well. So we are basically talking about the common variable with the lowest exponent. That's what we do when we take out the highest common factor letter. Hey said 0 Zen, I hope you're well. And then sometimes, I'm doing very well, thank you. Sometimes we have to take out not only the highest common factor letter, but at times we need to take out the highest common factor bracket, the common bracket with the lowest exponent. Sometimes in your terms you'll see that there's a common bracket, okay, that has the lowest exponent for your terms. Okay, then after doing so, that highest common factor we take out. Then 5, we write the leftovers. What is left over for each term? Leftovers in brackets. We write the leftovers in brackets. Then 6, check that what you have inside the brackets, can you apply further factorization? Okay, can you apply maybe difference of 2 squares factorization, or can you apply sum of 2 cubes factorization, or difference of 2 cubes factorization, or grouping factorization, or is it possible that this is a trinomial and a not be 1? Do we need to apply advanced trinomial factorization, or do we need to apply basic quadratic trinomial factorization where a is equal to 1 and you have to apply that kind of factorization? When you have checked out all the different types of factorization that are possible for what is in the bracket and you cannot factorize any further, you then do your last check, which is inside the brackets. Are there any like terms? Because if they are, you add them and you simplify what is inside that particular bracket. So inside the bracket, you simplify as far as possible. And if there's nothing else to be done, then that's where you actually stop and you know you are done with your factorization. Okay, so for instance, when we looked at this problem, we saw that there are how many terms? That's the first question we ask. There are 2 terms. Question number 2, should we apply the sign change rule? So here in this problem, we could see that the sign change rule can be applied. We can go that direction. Take out the negative sign, x cubed first, then minus 27 last. Then we look inside the bracket because we can see that by applying the sign change rule, a common factor has been taken out of a negative sign for the first term. Or we could reorder the terms and write them as negative x cubed first, followed by the constant, which is the right order in which to write your terms when you factorize. Then you can see, okay, is the highest common factor, which is the next question. Highest common factor sign, the first term is negative, so we take out a negative sign as the highest common factor. Whatever the sign of the first term is, we take out that sign as the highest common factor. Second, we ask, is there a highest common factor number? Well, there is a 1 here, and then this term has 27. So we ask, between 1 and 27, what is the highest common factor? So clearly, we take out 1 as the highest common factor. Invisible as it is, there's a 1 that is there that is taken out. 3, is there a highest common factor variable? In other words, is there a common variable for the terms or a common letter for the 2 terms that has the lowest exponent? Is there a letter that is common? X cubed is here. That is the only letter, which is the only term that has a letter. This term does not have a letter, so we don't have a highest common factor letter, a common variable with the lowest exponent, so we don't take that out. Then lastly, we ask, is there a common bracket? Well, for these 2 terms, there isn't. So that means the only highest common factor is negative 1. I take that out. Then, what is left over inside the brackets? You're left with x cubed for this first term. When you take out negative, you are left with negative 27 for the second term, because a negative times what gives you a positive? It is a negative sign. So we are left with negative 27 for the second term. This inside your brackets are the correct leftovers. Then you ask, is there any other type of factorization that can be applied inside the bracket? Well, you check. Is there a difference of 2 squares? No, this is a difference. But then these 2 terms are not perfect squares, so there is no difference of 2 squares. Is there a sum of 2 cubes maybe? No, this is a difference, it's not a sum. 3, is there a difference of 2 cubes? Well, x cubed is a perfect cube. How do you know that? Because x is raised to the power 3, and when you take the cube root of x to the power 3, you get a exponent, which is an integer. Alright, then 27 is also a perfect cube because the cube root of 27 is 3. So this is a difference of 2 cubes, which means I can apply factorization of difference of 2 cubes. How? We open 2 brackets, one for 2 terms, the other for 3 terms. This is a minus sign. So your first bracket will have a minus sign as per the bracket of the original. Then you take the cube root of x cubed. The cube root of x cubed is x. There it is. We write the x there. Then we take the cube root of 27. What is the cube root of 27? It is 3. Then, in order to write what is in the last bracket, the negative sign that you wrote there is followed by a positive and a positive, almost like clockwork. If it's a negative, we write negative, positive, positive. Always the case, guys. If it's a negative there, it's negative, positive, positive, negative, positive, positive, negative, positive, positive, negative, positive, positive. That is always the case. Then, to get the first term in this bracket, you square your x term. If you square your x term, you get x squared. To get your last term in this bracket, you square your last term in the bracket. Square of 3 is 9. To get the middle term, you multiply x and 3, ignoring the sign. If you multiply x and 3, you get 3x. And that completes your factorization. Do not forget to bring down that negative sign that you took as a common factor to your final answer. And then that completes that factorization. That factorization is done. We look inside the bracket. Is there anything more that we can factorize inside this bracket? All of these check out. There's nothing more we can do. Is there any simplification, addition of like terms that can be done in each bracket? These are unlike terms. These are all unlike terms. There's nothing more we can do. So then we stop right there. That means we are done with factorizing. Simple as that. If we come to 3.1.2, we repeat the same process. How many terms in the expression we are about to factorize? There are 1, 2, 3, 4 terms. Any sign change rule that can be applied? Is it necessary? No. Any highest common factor that exists? Well, for all the terms, we have a positive one highest common factor, but it is not significant. So that positive one, not significant, and really and truly, we are still left with these terms to basically look and factorize in this situation. We check now if there's any other type of factorization we have not considered for the 1, 2, 3, 4 terms. Difference of two squares? No. Sum of two cubes? No. Difference of two squares? No. Grouping? Well. Grouping seems to be something we can consider. If you look at how many terms we have 4 terms. That is an even number of terms. So let us look at n cubed and n squared, negative n squared. The question is, can we group these first 2 terms and then group the last 2 terms in such a way that it will lead us to a common bracket for 2 respective terms? Well, let's check it out. For n cubed and n squared, is the highest common factor for just these 2 terms? Well, highest common factor sign, positive. Highest common factor number, 1 between these 2. Highest common factor letter or variable, we take out the common variable with the lowest exponent. So that means n squared, positive 1 n squared can be taken out as the highest common factor for these 2 terms. Then there's no common bracket for these 2, right, that we can take out. So that means our highest common factor is positive 1 n squared. The positive 1 is there. The n squared is visible, all right? Then when we take out n squared, what is left over? Take out n squared, you need n cubed. N squared times what gives you n cubed? It is n. N squared times what gives you negative n? It is negative 1. We close the bracket. This has just been factorized, these first 2 terms. We look at the last 2 terms. The last 2 terms are negative n plus 1. We repeat the process. Is there a highest common factor between negative n and positive 1? Well, there is. What is it? It is highest common factor sign. We take out the negative sign as the highest common factor for these 2 terms. Because remember, when the term that we are looking for, the terms that we are looking at, the first term is negative, we take out that negative sign as the highest common factor. Then we ask, between the invisible one that is there and 1, what is the highest common factor between the numbers? It is 1. So we have a negative 1 as the highest common factor. Is the highest common factor letter? N is not common, so we can't take it out as the highest common factor. Is there a common bracket between the two terms? Well, there's no common bracket with a lowest exponent. So that means -1 is the highest common factor. What are we left with inside? -1 times what gives me -n? It's positive n. -1 times what gives me +1? It's -1. So therefore, I am done factorizing here. I have n minus 1. If you look at this expression now, how many terms do you have in this entire expression? Well, you have one term, because bracket makes this n minus 1 become 1. The relationship of n squared with the bracket is multiply, and multiply combines terms. So we have one term here. There's a minus sign, it separates. Two terms, so we have two terms in total now. How many terms do we have? 2. We ask, is there a need to apply the sign change rule here? No, because we have brackets that are the same, n minus 1 and n minus 1. Is there a highest common factor? And by that we ask, is there a highest common factor sign? Well, it is positive. Is there a highest common factor number? Yes, it is +1. Is there a highest common factor letter? We look at n squared and we look at n minus 1. There isn't. Is there a highest common factor bracket? Well. If for this term we have n minus 1, for that term we have n minus 1. So the common bracket that we can take out as the highest common factor is n minus 1. So we can write n minus 1. And when we write n minus 1, the question is, when we take it out, what's left over on the left? We are left with n squared. What is left over on the right? We have -1. So that is factorizing, taking out a common bracket of n minus 1. We're left with n squared on the left. We're left with -1 on the right. Then we ask ourselves, can we factorize any of these two brackets any further? Guys, when you look at n minus 1, there's nothing more you can do with this bracket. When you look at n squared minus 1, you notice that there is more that can be done with factorizing this bracket. So what is this type of factorization that we can apply for this bracket? We have n squared, we have 1, we have a minus sign. What does the minus mean? Difference. What does the n squared tell us? We have a perfect square variable here. N is a letter, it's raised to the power 2. Any variable raised to an even exponent is a perfect square variable. 1 is a perfect square number. So we have a difference here of what? 2 perfect squares. So when we are factorizing a difference of 2 perfect squares, what do? We open 2 brackets. So we are going to open 2 brackets for n squared minus 1. Then we are going to put a plus and a minus sign, because -1 means the signs inside the bracket are going to be different. Then we are going to take the square root of n squared, which gives you n. That means you are going to write n and n for the first term in each bracket. You take the square root of 1, you get 1, which means you are going to write 1 and 1. That is factorized. Factorizing n squared minus 1, because it is a difference of 2 squares. And that is the factorization. When I look at each bracket, is there anything more that can be done as far as factorizing each bracket? No. Are there any simplifications that you can do within each bracket, meaning like terms that you can add and so forth? No. Therefore, the answer, we stop right there, we underline, that is done. So guys, I hope that recap or refreshing of the factorization was really helpful. Let us never forget our golden rules, steps as we factorize given questions. Now guys, we're going to move on to the next question that is up, and that is this question. 3.2 says, if x to the power -1 plus x is equal to 6, prove that 2x to the power -2 plus 2x squared is equal to 68. If x to the power negative 1 plus x is equal to 6, prove that 2x to the power negative 2 plus 2x squared is equal to 68. Right. So when we analyze this question, it's a out of the box kind of question. And what it requires our application of mathematics as far as we have learned certain things within the grade and context. So this is what we have. We need to prove that this can be expressed as that. So if we take this and write it down, x to the power negative 1 plus x2 plus x is equal to 6. We are looking at this and we are asking ourselves the question, okay, how does having x to the power negative 1 all of a sudden get us having x to the power negative 2 and x to the power 2? What happened? All right, so we need to then apply something to the equation, but we need to do that thing on the left and then balance it out on the right so that it does not change the state of our equation. Our equation needs to be always balanced. What we do on the left, we must do on the right. So I am thinking to do something that would make sense would be to take x to the power negative 1 plus x and square it on the left hand side. But remember, if you are going to square x to the power negative 1 plus x on the left, then you need to square it on the right so that it is balanced for an equation. Okay? Do you guys see where I'm going with this? Square it on the left, square it on the right. What is the objective of doing that? I can see that there's an x to the power negative 2 and an x to the power 2. My focus is there. All right. And the reason why my focus is first there is because I'm thinking of BODMAS and how BODMAS says brackets and then orders. Now, orders means exponents and roots. So I'm actually wanting to then apply something that will affect the exponent of negative 1 and the exponent of x so that I get this x to the power negative 2 and x to the power 2 as well. So I am thinking of squaring the left, but what I do on the left, I am going to do on the right. If I square the left, I'm going to square the right. Hello, Seth, I hope you're well. So because of B brackets O orders, because in BODMAS, orders means exponents. So I square the left hand side of my equation. But what I do on the left in an equation, I'm going to do on the right. And I think in my order of BODMAS, applying that on the left and on the right is very much appropriate. Okay, so let us apply this exponential work. I can see additionally that in this other equation, there's a 2 before x to the power negative 2 and there's a 2 before x squared. And then all of a sudden I have 68. But here on the side, there are no 2's, there are no 2's. And obviously here, this is a smaller number, which is 6. It is not 68. So let us first take care of the exponents as per BODMAS. O orders exponents. And then we will take care of something later. All right, let's just focus on the exponents. Let's square both sides. But please now, don't apply the wrong mathematics as you apply the square on these two terms. You can't apply the square on the individual terms. You can't, for instance, do this. Okay, this is mathematically incorrect. You can only, because there are two terms here, you can only put the bracket around the two terms and then square them. This would be considered illegal mathematics and wrong. We would not dare do this because it is wrong. So if we square both sides, then we have to put brackets around the two terms and then square it. Then remember, when you have two terms inside the brackets and you are squaring like this, it's like you are opening two brackets like that. Okay, let's not forget that. And then what do? You take x to the power negative 1, you multiply with x to the power negative 1. What happens? X times x. You keep the base for exponents, then you add the exponent. So that's like saying negative 1 plus negative 1 there at the top. I hope we are together there. You take this x, the same one, you multiply with this x. So that's like saying positive times a positive is a positive. 1 times 1 is 1, then x to the power. Remember, this is negative 1 plus the exponent that you can see is plus 1. Then you take this x, you multiply with that one. Okay? So you distribute this term to that term to that one. You are done distributing this one. Then you take this one, you do the same. You distribute it to the first term, you distribute it to the last term. When you distribute, you are multiplying, guys, the sign, the number, and the letter, S and L. So we are doing the same thing here, x times x. That's x to the power 1 plus minus 1. Why are you saying plus? We are adding. When you are multiplying same bases, you keep the base x, you add. There's an exponent 1 that you can see there. So it's 1 plus a negative 1. Then lastly, x times x. That's like saying x to the power 1 plus 1. Okay. Then remember, we were squaring 6 on the other side. 6 squared is 36. Now let's continue and finish off here. X to the power, what's negative 1 plus minus 1? That's like saying negative 1, a positive times a negative gives you a negative. Plus x to the power negative 1 plus 1, that gives you x to the power 0, because 1 minus 1 is 0, plus x to the power, same thing here, 1 plus minus 1, that's like 1 minus 1, which is also 0. Because a positive times a negative is a negative, and 1 minus 1 is 0. Plus x to the power 1 plus 1 is 2. Snoko. That's what the song says. Jaiva snoko. Ulama boto 1 plus 1 is 2. Is equal to 36. We are not done. Then negative 1 minus 1. Hi guys, this one. Negative 2 and 2. X to the power 0. In exponents, what did you learn? Any base raised to the power 0 gives you 1. X to the power 0, 1. X squared is equal to 36. Then, what do you have here? Like terms. So x to the power negative 2 plus 1 is 2. Plus x squared is equal to 36. You take now this term, which is 2. You can transpose it to the right, because it has a like term on the other side. X to the power negative 2 gets left behind, plus x to the power 2, which is equal to 36. You take the 2 over, plus 2 minus 2. You get 34 for your subtraction there. 36 minus 2 is 34. Here, you have x to the power negative 2 plus x squared. Okay, guys, we have just successfully squared the left and the right, and I've shown you step by step how it is that I was able to get here x to the power negative 2 plus x squared is equal to 34. Now, that was squaring both sides, applying the exponent 2 to the left for both terms, not squaring individual terms, no. squaring the entire two terms by putting them in brackets and then opening two brackets and applying Mr. Foil, multiplying the first and the first, multiplying the outer terms, multiplying the inner terms, and then multiplying the last term in each bracket. And step by step, this is where I'm at. I can't go any further. Now, let's go back and check what did we want to actually see. The only thing missing now is the 2. Do you see that? The only thing missing now is the 2. We don't have 2 multiplied to that x to the power negative 2 that we now have currently. We don't have 2 here, and 68, the number we have there is 34. So what are we going to do now? We are going to backtrack and ask ourselves, okay, or does the exponent that we multiplied for both terms was x to the power, was to the power 2? Division, we have nothing. Multiplication, is there something that we can multiply on the left and then do the same on the right, so that we can have 2 as the coefficient of x squared and x to the power negative 2, and then that will change that? Well, I'm thinking that we can. Very good, Sekhame, it's very good. We can multiply everything by 2. So what I do is I multiply, take 2 and multiply the 2 terms. But what I do on the left, I do on the right. So you see now, I can go ahead, because I've multiplied by 2, put everything in brackets. Now I can distribute, applying the distributive law, DL, distributive law. Take the 2, multiply it with x to the power negative 2, that gives me 2x to the power negative 2. Take the 2, multiply it with x squared, that gives me 2x squared. Then what's 2 times 34? That is 68. Voila. Voila. Who would have thought? All right. I actually was able to use this, because that was my if part, and I was able to prove that to be something that actually does exist. Okay, so there it is, proven. Okay, 4 marks in the bag, and I smile. So hopefully that's clear. Yeah, it's clear. It should be. Okay. It should be. Okay. So now let's continue with the rest of the paper, because there's more questions here. Now the next few questions are saying we need to solve for x. So if we look at this, thank you so much for that, the likes there. I really like the likes, thank you guys. Solve for x. Now we are entering into the solve for x zone. 4.1.1, 3x minus 5 is equal to 7 minus 5x. Now for a grade 10 learner, guys, this is a typical grade 8 question. This is a grade 8 question. 4.1.2, you are in grade 10. This is a grade 9 question. 4.1.3, you are in grade 10. This is a grade 8 question. So these 3, in the level grade that you are in, these are actually really just giveaway marks. All right, and it's a 2 mark, 3 mark, 3 marks, 6 plus 2, you have 8 marks, which you should get easily, not a problem. So let's look at 4.1.1 and quickly just do it. You should be able to do it yourself. Very, very simple and basic, these questions, all of them, but they just need our foundational knowledge of the basics, and if we have those down, not a problem, straightforward, to the point. So if we look at 3x minus 5 is equal to 7 minus 5x, we look at the left, we have 1, 2 terms. We look at the right, we have 1, 2 terms. If we look at the type of equation we have what I call a linear equation. Why? Because the x variable, both of them have the highest exponent being the exponent 1. When that is the case, you simply do this. You isolate the x terms on the left. So you have 3x here. There's a negative 5x. You transpose, you move negative 5x to the left. Okay, we are applying the additive inverse law, but then we move negative 5x as a shortcut, which basically means when negative 5x goes over, it becomes positive 5x. Then the 7 stays on the right. The negative 5 joins it. Okay, the negative 5 joins the 7 on the right hand side. When negative 5 goes over, it becomes plus 5. So there's a simple change of sign whenever terms that are separate move to the left or the right. So we call this the additive inverse. 3x plus 5x is 8x. 7 plus 5 is 12. We need to isolate x to be on its own. The 8 is multiplied to x. So how do you get rid of the 8 that is multiplied? You use the inverse of multiplication and you do what? You divide both sides by 8. Okay. Then the 8 and the 8 divided by 8 is 1. So that means you are left with 1x. Okay. And then on this side, 12 divided by 4. Guys, between 12 and 4, the highest common factor is 4. So 4 goes into 12. 4, 8, 12, 3 times. And then 4 goes into 8. How many times? 2 times. Okay. So at the end of the day, you get an answer of 3/2. Amanda Burr, I came back. I only speak English, but I understand a little bit of what you explained. Do you mean Spanish? I think you are the one that said you speak Spanish. I think that's what you said. I don't believe you. You mean English. I think I saw you. You were here yesterday, but you said I think it was Spanish, right? Yeah, Spanish a little. I came back. I only speak English. I am speaking English. That's what I'm speaking at the moment. All right. Let's go here, guys. X squared minus 3x plus 2 is equal to 0. So now we have this equation, and it is not a linear equation, but so this one was linear because the highest exponent that existed was x to the power 1. This one, we call it a quadratic equation. Why? Because as its highest exponent, the variable that has the highest exponent is x to the power 2. Okay, I hear you now. So x squared minus 3x plus 2. This is a quadratic trinomial. In other words, this is since the variable with the highest exponent is 2, we call this quadratic. Then we say it's a quadratic trinomial. Why trinomial? There are 1, 2, 3 terms. 3 terms in an expression means trinomial. Okay, so we are going to, with a quadratic trinomial, we need to make sure that our equation first is in standard form. By standard form, we mean the expression should be in the form of ax squared plus bx plus c. As you can see, it is already ax squared minus 3x plus bx plus 2 plus c. So this is in standard form. That's what you first do. 2, you need to then factorize the quadratic trinomial. How do we factorize a quadratic trinomial as this? Okay, here we need to first check, does 2, are there factors of 2 when we multiply give us positive 2 and when we add them give us negative 3? I repeat, does 2 have factors which when we multiply give us positive 2, but then when we add them give us negative 3? If it does, then you can go ahead and factorize this trinomial in the way that it's supposed to be. Very good, Amanda. It is negative 1 and negative 2. So the factors of 2 that you multiply that give you positive 2, but then when you add them, they give you negative 3, is exactly what you've said in the comment section. Great job, Amanda. Great job, Amanda. You are phenomenal. So what we do then is we open two brackets like this. And I personally would say this positive 2 means you are going to have the same signs inside your bracket. I repeat, if you have a positive sign here, it means same signs. Okay, that's what it means. Same signs according to what? According to the sign of the middle term. So I know that I'm going to have the same signs and they are both going to be negative. So let me repeat this again. I'm saying when you have a positive sign for your constant and your a value, your coefficient of x squared is 1, positive 1, then we say that this means same signs. According to who? According to the sign of the middle term. So we know these are negative, negative. If it was positive and another positive, we'd know still positive means same signs. According to who, it would be the sign of the middle term. So we'd have a positive and a positive. But in this case, we are having a negative and a negative. Then we think of factors. Amanda has already told us. Factors of 2, which when we multiply give us positive 2, and when we add them give us negative 3, are 2 and 1. And you can see they are both negative. Then guys, to get x squared, it's simply x times x, which gives you x squared. Factorization complete for your trinomial. Now, after factorizing, we apply what I call the zero factor law. What does the zero factor law mean? There must be a 0 on the right and a product, meaning a multiplication of factors, x minus 2 and x minus 1, which will lead me to do this: x minus 2 equal to 0 or x minus 1 equal to 0. You can only do this, what I've just done here, when there's a 0 on the other side. If there's another number, you can't do this. Then after the zero factor law, you get your roots of the equation. In other words, your solutions. This is a linear equation. There's a minus 2. You simply take the minus 2 over, it becomes positive 2. Or this is another linear equation. You simply isolate x, you take negative 1 over, you get positive 1. And those are your two solutions. Very good, Amanda. You change the signs. Very good. Very well. Straightforward. Okay. Then the last question for our equations, solving equations, is 4 to the power x plus 2 is equal to 8 to the power x. Here, what do we have? We have an exponential equation. It's not quadratic, but it's an exponential equation. When we solve exponential equations, guys, the objective is to have the same numerical bases on the left and the right. Currently, there's a 4, there's a 8. These bases are not the same. So in order to make them the same, we take this composite base. Guys, we have what we call composite bases. These are bases that basically are numbers that have more than 2 factors. For instance, 4 has more than 2 factors. Okay, the factors of 4 are 1, 2, and 4. That's more than 2 factors. The factors of 8 are 1, 2, 4, and 8. That's more than 2 factors. So we call these composite numbers, composite bases. So we need to change the composite base to what I call a prime number base. We need to convert these to prime numbers. So 4 can be written as what? as a prime number. What is a prime number? A prime number is a number that has only two factors, 1 and itself. So 4 can be expressed as 2 to the power 2. Once you convert a base to a prime base, you write it in brackets. Then that x plus 2 there on the outside. 8 can be written as 2 to the power 3. Alright, very good, thank you. You 2 to the power 3, 8. You put the x on the outside. So when we convert, please put in brackets what you convert. Okay, that's step 1. Step number 2, we can now apply law number 3. What does law number 3 say? It says when you have a base raised to a certain exponent and there's another exponent on the outside of that bracket, you can simply multiply the exponents, m times n. So we're going to do that likewise here. You have 2 to the power 2. There are 2 terms outside this bracket. So that means we are going to distribute the 2. 2 times x, we are going to get 2 to the power 2x. 2 times 2, we are going to get 2x plus 4 as our exponential expression there. Then lastly, 3 times x, 2 to the power 3x. Now, what we can see is that we have the same numerical bases on the left and right of our equation. What does that then mean? There's a law or a property that says if a to the power x is equal to a to the power y, in other words, the bases are the same on either side of the equal sign, then x is equal to y. In other words, the minute or the moment the bases are the same, you can drop those bases and you can equate the exponents. So x is equal to y when the bases are the same. So here, applying this property, what can we say? 2 to the power 2x plus 4 is equal to 2 to the power 3x. The bases are the same. So what do we say? 2x plus 4 is equal to 3x. Yes, we equate the exponents. Then, what are we now at? Step number 4, we have what we call a linear equation. If you remember a linear equation, we saw how we deal with a linear equation, how we solve for a variable with a linear equation. So we are there now. We are back there, linear equation. This exponential equation has just taken a turn. It is now a linear equation. So let's solve it. 2x on the left, we take the 3x over negative 3x. We take the 4 over, we isolate the variable. Remember with the linear equation, we always isolate x and on one side and we isolate the numbers on the other. 4, that is positive. What happens to 4? The 3x went over, changes to negative. The 4 needs to cross over, it becomes negative. So then we are left with negative x is equal to negative 4. Finally, we divide both sides by negative 1, the coefficient, because remember our variable has to be positive. What we do on the left, we do on the right. So a negative divided by negative is positive, a negative divided by negative is a positive, but our answer is positive 4. Done. Okay, that was not too difficult, was it? Okay guys, hence I'm saying this is basics that we need to make sure that we can do well. And when we can, what a joy it is, because the marks will flow. We will not have issues, problems that will basically be incumbent upon us. So nice work. Let's move on, guys. We have 4.2, right? With the remaining minutes that we have, 4.2, solve for x in the inequalities below for x as an element of R and show the solutions on a number line. Read the question, solve for x in the inequalities for x is an element of R and show the solutions on a number line. 2x minus 1 over 3 is greater than or equal to x plus 3 over 2. This is a linear inequality, but it has a denominator, so we have fractions on the left and the right. 4.2.2, this is another linear inequality which we need to solve, but then please take note, it says we need to solve for x in the inequalities below for x is an element of real numbers. What this means is that for every x value that is a real number, real numbers, guys, are all the numbers in the number system. So we are basically saying for any value of x, we need to show the solution after we are done on a number line. Guys, this is an important aspect, showing the solution on a number line. Okay, so 4.2.1, let's go ahead and write this. 4.2.1, 2x minus 1 over 3 greater than or equal to x plus 3 over 2. So, inequality. So, we would want to get rid of the denominators. How do we get rid of a denominator? 2x minus 1 over 3, this is one term, greater than or equal to x plus 3 over 2, this is also one term. Our denominators are 3 and 2 respectively. How will we get rid of those 3 and that 2? Well, we have something that we call the LCD, which comes from the LCM. What is the LCM? LCM is the lowest common multiple. So we are going to check between 3 and 2 generally. What is the lowest common multiple between 3 and 2? A lowest common multiple, guys, is that number which is a multiple of both of these numbers, but it is the lowest number which is common as a multiple for both of these numbers. So in other words, if you are counting in threes, your multiples of 3, 3, 6, 9. If you are counting in twos, 2, 4, 6. We could go on 3, 6, 9, 12, 2, 4, 6, 8, 10, 12. Check this out. We are wanting to see which is the lowest number which is common for both the multiples of 3 and 2. Now, 6 is the lowest common multiple. Yes, there are other common multiples like 12. But when we want the LCM, we want the lowest one, not the highest one, or the middle highest one, or the middle lowest one. We want the lowest, the lowest of the lowest, the scum. So basically, that means our LCM of 3 and 2 is 6. Sorry, why did I write 2 now? Is 6. Therefore, yes, we know that we are going to say that the LCD is 6. After doing so, we need to multiply each fraction. Each fraction term we multiply by LCD, which is 6. So what I'm going to do is I'm going to say 6, and we multiply by the LCD in the numerator, not in the denominator, in the numerator. So you're going to say 6 times the 2x minus 1 over 3 greater than or equal to 6 times. Okay. So there is something that then can be done with the 6 and the 3. The 3 and the 6 can be cancelled. Why? Because the relationship of 6 with 2x minus 1. Guys, you make sure to put 2 or more terms in the numerator. When you are doing this, must be put in brackets immediately. I'm going to say there's 2 or more terms in numerator. Always put those in brackets. There is wisdom in doing that, guys, because it keeps things orderly and safe. So that's why I have me putting 2x minus 1 in brackets. X plus 3, it's 2 or more terms, I'm putting it in brackets. 6 multiplied by that. The relationship between the two is multiply with division. So therefore, cancellation can happen if it is a multiplication relationship. It's not a cross and addition or subtraction sign, but it is basically due to multiplication that we are, okay, with division. So 3 goes into 3 once, 3 goes into 6 twice. 2, 6 and 2. 2 goes into 2 once because it's the highest common factor between 6 and 2. 2 goes into 6 3 times. So what are we left with, guys? 2 into 2x minus 1, which is greater than or equal to 3 into x plus 3. Now, the fact that we have a number 1 as a denominator, basically that 1 is not significant, so we can leave it behind. 1 is only significant if it's left behind in the numerator alone. We would show it if it's in the numerator. Okay, if it's alone in the numerator, we would reveal it. But if it's 1, it's left over in the denominator. It's insignificant. We don't have to show it. Then we can now solve. 2 times 2x into 4x. 2 times negative 1 is negative 2. You do the same thing with 3 this side. You distribute the 3. 3 times x is 3x, and 3 times 3 is 9. And what you simply do is you are going to isolate the x values. Okay, by transposing, you isolate the numerical values on the right by transposing. So the negative becomes positive 2, the 3x becomes negative 3x. 4x minus 3x is x, which is greater than or equal to 11. Guys, we are not done because remember they said show the answer on a number line. So what we do is we draw a number line. We just put 11 there, okay? Because we are being told that x is greater. In other words, x is bigger. The values that satisfy these inequalities are values that are bigger than 11. What does that mean? Real numbers. Remember they said x is an element of real numbers, okay? And it is also equal when x is greater than 11 but also equal to 11. So exactly at 11. So we shade because the equal sign leads us to include 11. The greater than sign makes us draw an arrow that basically is an indication that every single value of x which is bigger than 11 will basically satisfy the inequality as well. Why are we shading the dot? It's because there's an equal sign. What would we do if there was no equal sign? We would draw an open dot that is not shaded. But because there's an equal sign, we shade the dot. But if there was no equal sign, if it was just x greater than 11, we would have an open. We would like, if it was x greater than 11, guys, we would basically have a number line where we have 11. We open the dot to show that 11 is not included, but then we would draw the arrow to indicate that every other value we would take into consideration, because all real numbers after 11, meaning all rational and irrational numbers, would be part of our answer. But we include 11, we have a shaded dot. That is how you represent your answer on a number line. And that's that. Okay, guys, it's straightforward like that. 4.2.2. Let's look at the other inequality here. Okay, the next one. 2 into 2x minus 3 minus 4 is greater than or equal to 2x. Okay, so here we have how many terms on the left? 1 minus sign 2. Then on the other side we have 1 term. So if we look at the terms, there's a 2 multiplied, so we know most when we do have that, we distribute the 2 there. This negative 4 is alone, it's not affected. 2 times 2x is 4x. 2 times negative 3 is negative 6. Then the minus 4 there, greater than or equal to 2x. Then we add like terms. This is a linear inequality, and we are going to isolate the x on the left, take the 2x over, negative 2x, take the negative 4. Negative 6 minus 4 is negative 10. Take the negative 10 over, becomes positive 10. Let's just write 6 plus 4 here so that we can see it. 4x minus 2x is 2x. Greater than or equal to what? 6 plus 4 is 10. Then what do? We divide both sides by the coefficient, which gives us x is greater than or equal to 5. Remember, we need to represent our answer on a number line. So when we do, we just go down there, write down the number 5. Still, the 5 is included. So what do? We shade, a shaded dot. We draw an arrow. X is bigger, so bigger numbers lie on this side of the number line. Okay, and that's that. Done, finished. Number line representation, not a problem. Okay guys, I'm going to look at 4.3, 4.4 and 4. Yeah, 4.3 and 4.4. We'll save 4.5 and 4.6 for tomorrow. So let's look at 4.3 and 4.4. The question says solve for h if j is equal to h squared over w for when h is greater than or equal to 0 and w cannot be 0. Okay, these are, restrictive things that we are being told here. Remember, if w is 0, then we would have a problem because it would mean that the equation is undefined. So they are just putting a restriction to say w cannot be 0, which makes sense, and it's very much appreciated that. So they're basically restricting us from having w being 0. Also, they're saying h is a positive value, or it can be equal to 0. Okay, yeah, they are saying h should be a positive value because anything greater than 0 means it's positive, and then also equal to 0 means it can be equal to 0, at least in the numerator it can be. Okay, so there's nothing to that. But then what are they saying? Solve for h. So in other words, we need to isolate h on its own and then write it in terms of j and w. Okay, so when they're saying solve for h, in grade 10 we call these literal equations. All right, it's when we change the subject. Currently the subject of the equation is j, because j is isolated. Now what we want to do with this is we want to isolate h and make h the subject. That's why they're saying solve for h. So let's see how do we go about doing that. J is equal to h squared over w. Guys, it's good to know the relationship of things with other things. Okay, currently you have j. Okay, j can be written, j is actually j over 1 on the left. Okay, the thing is, you don't see this, but it's something that's there. Then h squared over w. So what you want to do is you want to isolate h. You want h to be on its own. Okay, because they are saying solve for h. But currently, what relationship does h squared have with w? H squared has a division relationship with w because the line here means divide. H squared is divided by w. Does that make sense, guys? Hey, I hope you understand that. H squared is divided by w. So what we want to do to get h squared on its own first, we want to get rid of w. How do we get rid of w that is in the denominator? How do we get rid of a w that has a relationship with h squared of division? Well, we use the inverse of division, which is multiplication. So what would you do on the left of your equation? You will multiply by w in the numerator. Why by w in the numerator? That's how the w in the denominator will be get rid of. But then remember, with equations, to balance them, what you do on one side, you must do on the other. So which means I'm going to multiply by the same thing on the right. Okay, we call this, guys, the multiplicative inverse. Okay, the opposite of divide is multiply. The opposite of multiply is divide. This thing is like when you want to get when you want to isolate x, you're asking yourself, what is the relationship of 2 with x? 2 and x are combined by multiplication. So how do you get rid of this 2 so that x is isolated? You divide by 2. You see, guys, this thing. But what you do on the left, you do on the right. This time, we want h squared on its own, but it has a relationship with w. W is in the denominator. How do you get rid of w? You multiply by w. Where? In the numerator, not in the denominator. Because if you multiply by w in the denominator, you're going to get w squared. It's going to make things more complicated. You multiply by w in the numerator. Then what you do on one side, you do on the other. Now check what happens. They go, I'm left with 1 and 1. On the right, h squared is on its own. On the left, w times j is wj. Guys, can you see how close we are to having h isolated on its own? Currently, h is not on its own. It has a square. You see? So that square also needs to bounce, needs to vamoose. So the question is, what do we apply to a square in order to get rid of it? Because whatever we do to this here, we're going to have to do on the side. Okay. So the square has a inverse that we call the square root. A cube has an inverse called the cube root. Any other to the power whatever exponent will have its inverse as whatever that is its inverse root. Are we together? So I have h squared. This guy needs to go. So what we do, we take the square root. What we do on the left, guys, we do completely on the right. Completely on the right. So this square and square root, goodbye square. H, hello, you are on your own. Wj, you are now having a square root. And now we can say, therefore, h is equal to the square root of wj or jw. Doesn't matter. Remember, multiplication is commutative. Whether you start with j and end with w or start with w and end with j, doesn't matter, because 3 times 4 is the same thing as 4 times 3. In maths, we know that multiplication is commutative. The order in which you place things when you multiply does not matter, because the answer is still the same. Anyways, so that's that. Okay, and this is a useful tool to use when you are dealing with equations, even in physics, right? Because when you know how to manipulate to change the subject, it means you can basically do that for anything. Let's move on to 4.4. They have V is equal to U plus AT. If you are a physics student, you know what this formula is for. Now they are saying solve for A. So what you do, because you need to solve for A, you ask yourself, where is A? There is A. What is the relationship of A with what is around A? First, you have A with T. They are multiplied together. This AT, there's an addition to it of U, right? And then there's V on the other side. So how do we make A the subject of the formula? It's very basic. First and foremost, this U, all right, needs to go. How many terms on the right? 1 plus, then there's 2. So U needs to go. How do we get rid of U first? First, let's get rid of U. So U can be transposed because it is a term that is separate completely from AT. So we can say V minus U is equal to AT. Not a problem. We are very close now to isolating A. How now are we going to isolate A? Well, T needs to go. But what is the relationship of T with A? T and A are multiplied together. So how do you get rid of something that is multiplied to another? You do what? Do you want to tell me before I tell you? How do you get rid of a T that is multiplied to A? Okay, we use the inverse, which means we are going to divide by T. But remember what you do on the left, you do completely on the right. Okay, so the T and the T cancels. We are left with A, and that is V minus U over T. Done. We can then maybe rewrite it. Okay, A is equal to V minus U over T. This is the formula where A is the subject. We have just written A in terms of V, U, and T. Okay. Guys, I think that's all I can deliver for today. I hope this session was really beneficial and helpful. All right, I'll finish off tomorrow by doing these last two questions with obviously explanations of how we do those. All right, but I hope this was a beneficial video to you and was helpful. Please guys, if you haven't subscribed to my YouTube channel, please do subscribe. I really appreciate the subscription. And also like the video, comment, when it's uploaded, please do share the channel with other friends and people that you may know that maybe may be struggling with maths. This is especially obviously applicable to learners that are in grade 10, because this is grade 10 revision prep for March. You people can rewatch the live video if they missed it in the morning. Please share this with everybody and anyone that is in grade 10. It may be very helpful. It may just save a learner who is thinking about quitting pure maths and grade 10, which would be a terrible mistake to make if it is on the basis of not understanding the basics in grade 10 so far. There is a way to understand, and I think people just need to give themselves time to learn and to understand so that things can flow. Thank you so much. I hope you guys have a great one, and I'll see you again when I see you. Cheers. Man, maths is a game, guys. Let's play the game and play it some more and play it some more.